And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and we're looking at the closest star here. And we see multiple C-class X-ray flares, mainly from sunspot 2816, sunspot 2817 setting up here in the northwest, sunspot 2818 less likely to produce any significant enhancements. The coronal mass ejection watch continues, folks. So we'll be talking about that, solar flares, and also talking about stellar flares. First thing we'd like to do is thank our patrons. Please consider becoming a patron and funding our operation, as we're paid just this side of nothing to put the videos on YouTube. Patreon.com/smAshomash if you'd like the first alerts, all kinds of other multimedia perks, and so on. Patreon.com/smAshomash. Here's the southern hemisphere in magnetogram. Sunspot 2816 has actually degraded over the past 24 hours. Sunspot 2818 has stayed rather stable. Likelihood of solar flares has dropped a little bit as a result of the degradation of sunspot 2816. Again, likelihood of coronal mass ejections is still quite significant, as we've got a ton of filaments around both polar regions. Here you can see some of them in 304 angstroms ionized helium. Right here, this is a long line of filaments. Also some filaments here. And if a coronal mass ejection should occur, we'll make a video about it. Here's the same area in 171 angstroms, ionized iron. And you can see some of those filaments reaching up off of the edge of the southeastern solar limb down there on your screen lower left. Here's the setting of sunspot 2817, and we'll show you an extreme close-up of that to close out the video. Here's a diagram of the solar system. There's where things will be in a week as Mercury speeds around from the backside of the sun to catch up with Earth. Here's a star chart. If you're up before dawn, you may see Saturn and Jupiter. If you've got a clear sky and a view of the ecliptic, which is this yellow line, the ecliptic being the path which the sun takes across your sky. The radio flux now up to 84 solar flux units, as the upper chromosphere and lower corona emit radio signals in the frequency of 2800 megahertz. 84 is the radio flux number. Here's a one-year chart. It's this upper black line. The lower red line here is the sunspot number. And NOAA's forecasting a coronal mass ejection strike from the coronal mass ejection that we covered recently on the channel. NOAA's forecast is for it to arrive early in the day on the 25th. You can see an increase in the density and velocity of the incoming solar wind expected to increase by NOAA. At that point, we forecasted this as a miss to the east. We'll have to see who was correct. You can see they're forecasting a G2 geomagnetic storm from that. Sounds a little over the top to me, but that's the forecast from NOAA there on the 25th, about midday, expecting a geomagnetic storm condition as a result of the coronal mass ejection. Let's check earthquakes over the past 24. A deep quake at Fiji, a deep quake at Alaska, a deep quake at Japan. No major quakes over the past 24 hours. Nothing very far over a 5 magnitude. In fact, I think a 5 magnitude is the largest quake of the past 24 hours here. A deep quake at Afghanistan. A deep quake at Fiji. So a second one there near Fiji. Again, no large quakes over the past 24 hours. Another deep quake at Fiji. That one coming in at 2:14 on today, April 23rd, 2021. Year of accountability. By the way, welcome to the year of accountability, folks. Are you accountable? Are your government officials accountable for the debacle that was last year? Here's a 4.6 deep quake at Argentina and another deep quake at Afghanistan. Continuing on to check volcanoes at volcanodiscovery.com's Volcanoes Today page. Mount Abico producing a 7,000-foot ash plume. At Paramushir Island, Sakurajima on the Kyushu Island of Japan, 7,000-foot ash plume there. Mount Ibo exploding on Halmahera, Indonesia, 6,000-foot volcanic plume of ash above it. Dacono exploding as well, 7,000-foot ash plume there. Fuego exploding in Guatemala, 17,000-foot ash plume there. Sangay and Revenador both exploding in Ecuador, 22,000-foot ash plume from Sangay, 14,000-foot ash plume from Revenador. Sabancaya in Peru producing sporadic emissions, and Soufriere in the West Indies on the island of Saint Vincent has been exploding, 7,000-foot ash plume there. A great reminder to please not pole vault the caldera. Please don't pole vault the caldera, folks. It could be unhealthful. And we like to put out these public service messages because people are stupid. So chances are you're not stupid because you're watching our videos, but people are stupid. So welcome to the neo-renaissance. We're hoping people are waking up from their stupid, idiotic, imbecile slumber. And by the way, imbecile is an adjective if you're wondering. Check out our own webpage, smAsho.com, as we saw the writing on the wall years ago about the failures of big tech as it circles the drain. We ask you if you'll be circling with it. We're not circling the drain. We're producing all kinds of awesome products, like our products here on Redbubble. If you want to check out the Redbubble store, head to smAsho.com, click on smAsho merch, and you'll find our products there. Let's get back to space data. The GOES X-ray Flux produced an ongoing series of C-class flares. Here you can see the data there from the GOES 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 C-class flares here in the past approximately 24 hours there, as the sun increases activity. No strikes in the proton flux. No surprises there. And here's the GOES magnetometer, one of the other space-facing instruments, the GOES magnetometer. And you can see quite spiky data here in the past few hours. Earth is going to be in a North Pole current sheet coming in about 24 to 36 hours. And here's a view of the current sheet. I would actually expect us tomorrow, when we make our daily space weather video, to be in the North Pole current sheet shown here in green. And there is some activity over there out in front of Stereo A. Perhaps check that out on Stereo A's website if you like. We'll keep you in suspense instead. Here's a line of sight ecliptic plane field plot. Essentially the same data, but from the perspective of line of sight. And you can see that North Pole current sheet moving in, that blue line dipping well into the southern hemisphere, an indication that the North Pole is about to take over the charge, the polarity of the current sheet in which you'll be located, most likely by tomorrow at this time. Here's a line of sight coronal hole plot, and you can see a large trans-equatorial coronal hole spreading down from the north, causing a bit of a change in the sun's B field shown here in blue. Here's the latest image. You can see these green dots over here. That is a North Pole-oriented coronal hole. And here's a view of the active sunspot regions and filaments. Now, some filaments are missing here once again. You can see it is noticing this one here, as well as these down here. Most of the filaments are showing up. Again, likelihood of coronal mass ejections is quite significant. We are expecting one. Coronal mass ejection watch continues until further notice. We also may see another sunspot forming up here in the northern hemisphere. That would be 2819 if it's there long enough to get a name. And the most likely place for significant solar flares is sunspot 2816, although, like I said earlier in the video, it has degraded over the past 24. KP index currently at 3, and for you new viewers, the KP index is a measurement of global geomagnetism. KP index currently at 3. Next, the real-time solar wind. Fairly uneventful here, although there are some shifts in the phi angle. Current solar wind density just under 7 protons per cubic centimeter. Solar wind speed 404 kilometers per second. Solar wind speed 404 kilometers per second. Solar wind density just under 7 protons per cubic centimeter. Here's a geospace magnetosphere movie. It's 4 hours of data showing magnetohydrodynamic pressure in nanopascals. And no surprises here, as we're seeing a fairly steady data set for solar wind density and speed over the past 4 hours. Also, we'll show you ground magnetic perturbations, geospace delta B, changes in the Earth's B field. This is in nanotesla. Keep in mind the other one is in nanopascals. The difference is nanotesla is measurement of the magnetic flux itself. Nanopascals is magnetohydrodynamic pressure. And we see some oddities here over the Antarctic continent. Check this out. I would direct your attention right down here. This like flashing of the fields down here, I've never seen that happen before. And it's someplace south of the South Geomagnetic Pole, which is actually up here someplace. South Geomagnetic Pole, folks, is someplace down here, south of Australia. Someplace like about here. But if you watch this region right here, you're going to see some odd pulsations happening there. As the South Geomagnetic Pole has left the Antarctic continent, now thousands of miles from the South Geographic Pole. Next, I would welcome our viewers from Twitch. So, welcome Twitch viewers. I've decided to stream live for another cosmology segment today. If you want to check out our Twitch streams, it's twitch.tv/smAshomash. My favorite streaming platform, period. Thanks to our followers over there. Also, thanks to our subscribers, new and old, over on BitChute. Please leave us comments and share the content on your social media. BitChute and BitChute users may be excited to realize that we'll be making some changes at smAshomash.com soon and creating subscription services over there. Thanks to our YouTube viewers as well. Thanks to our new subscribers, etc. Please share the content on your social media. Tell your friends and foes about the channel, as we need your assistance to grow the channel, since the algorithms have been, shall we say, less than helpful for the Smash News Network, least busted name in news. Today's cosmology segment should be interesting. First, we're going to go to the astronomy picture of the day. You can find it yourself at apod.nasa.gov. And today's astronomy photo of the day is a flyover. A flyover of planet Earth, which we officially announced was flat yesterday. I was just kidding, folks. You can actually see the Earth's curvature from this view. And yes, I know, it's because of a curved window, right? The curved window is making the Earth appear to be flat. I mean, to be curved when it's, okay, anyway. That's today's astronomy photo of the day, a great flyover from the International Space Station. And you can see some red and green aurora there on the edge of the imagery. The aurora borealis, folks. Let's talk about petatrons. Now, when gamma rays reach the Earth, they cause a particle shower known as Cherenkov radiation. This particular gamma ray sensor here is known as the High Altitude Water Cherenkov Observatory. And this is interesting in that powerful pulsars are responsible for accelerating particles to the point where when they collide with things, they produce electromagnetic radiation in the more than 56 tera electron volts. So we're talking about trillions of electron volts here, folks. Trillions of electron volts. And we've talked about pevatrons before on the channel. Check out our cosmology segments. You can find the whole playlist. There are like pushing 200 videos there now. youtube.com/smashamash/playlists. We've talked about petatrons before. This interesting article here about the source of petatrons, gamma ray producing pulsars. Let's talk about Comet Atlas C4, is it? Comet Atlas R4, yes. Remember, folks, never memorize something you can look up. That's a quote from Einstein. Comet Atlas R4 may become visible to the naked eye. Right now it's in binocular range. So this one discovered in September of 2020 by the Asteroid Terrestrial Impact Last Alert System known as ATLAS. Has been changing its magnitude a little bit. So this one may make it into visible territory soon. We'll keep you posted on that if it happens. And this is the image of Comet 1P Halley from back in the 1000s. And please leave us a comment if you're scared, spooked, and frightened. And there's a chart showing you where Atlas C2020R4 will be located from April 20th through June 1st. Showing you the constellations that it'll be moving through. What do you think? Do you have a forecast whether it will brighten and become naked eye visible? Again, it'll show up as bright as a moderately bright globular cluster right now. And there is some imagery of Comet R4 Atlas. Not much structure to it yet. We'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. Today's random number is 397, which coincides with Safer 2 Galaxy Swift J1200.8 plus 0650. And here it is on Aladdin Light. Great example of a Safer 2 Galaxy, and you can see the dust lane here, which is giving us some indication where the toroid is located. You can see this round feature, an indication that the jet is probably somewhat sort of like oriented like this. The opposing jet is probably somewhere something like this. You can see the torus is sort of like in this shape here. Safer 2 galaxies are a type of active galactic nucleus where it's pretty bright, but not as bright as, say, a quasar or a blazar. Let's take a look at it in a couple different frequencies here. Here it is in infrared light by the 2 mass, and you can see the heat signature of that totally different than some other signatures. Let's see if it shows up on Pan-STARRS. There it is on Pan-STARRS. Very high resolution imagery there from that observatory. And that is optical, by the way. And let's show you in Chandra as well. Doesn't show up in Chandra. Here it is on the multi-mirror XMM Newton project. The X-ray outputs from that. And let's take a look at another object, Proxima Centauri, as it is in the news as well. So this eruptive variable star, Proxima Centauri, is a red dwarf, and it's quite variable, put it that way. Red dwarfs are notoriously variable. Let's see if it shows up on the Chandra. There it is on the Chandra. Here it is on XMM Newton, as this is a binary system. How does it show up in blue light? And let's just put it on the XMM Newton. There's a great image of the Proxima Centauri binary system, folks. And this is an artist's rendition of a massive outburst which occurred in 2019. So this article from phys.org's Astronomy and Space section entitled Humongous Flare from Sun's Nearest Neighbor Breaks Record. So this increased in brightness 14,000 times in ultraviolet wavelength. It also emitted radio burst at the same moment, something that we see from the closest star as well, El Sol, the local yellow dwarf known as the Sun. And Proxima Centauri, again the closest star, quite variable indeed. This article again from phys.org's Astronomy and Space section. And that's today's cosmology segment. It's time to say goodbye once again to Twitch. See you later, Twitch. We'll invite you back for the meteorology segment. Continuing on with the daily space weather, here at the Smash News Network, least busted name in news. Here's the one-year chart of the electron flux, and we are still in very high levels of electron flux. Indeed, warning levels causing some satellite charging hazards undoubtedly. Here's the 3-day chart as measured by the GOES-16. And you can see we reached back into about 15 times alert levels there. At about 15,000 pulse flux units was the peak yesterday. And NOAA is expecting this to subside soon. I would tend to agree there. The green boxes are the forecast. The yellow diamonds are the observation. Here's a diagram of the Van Allen belts along with distances in miles. And feel free to pause the video if you must. Here's a total electron content visualization. This will show you the most likely spots for GPS errors, folks. It's showing you the whole air column, all the way from your GPS satellite down to your handset. And when your GPS has to communicate through a bunch of electrons, it can create massive errors. Here's another diagram of the atmosphere. We're showing this for the F ionosphere layer located here at 300 kilometers altitude. And here is the ionosphere map animation, courtesy of Australian Government Bureau of Meteorology. Each tick of the clock here represents 15 minutes. Ionosphere looking a little more normal here. Some major charge downs there at nighttime. You can see those blobs where the F multiple layer becomes an F1 layer. And what you're looking at here is megahertz, so the vibrational frequency of portions of the ionosphere. The resolution is 1 megahertz, millions of vibrations per second. And let's bring up the latest image here from 9 o'clock Universal Time. Not looking particularly abnormal there, although making it up to 14 megahertz over places just east of India. Next, I would note that it's time for a meteorology segment, and so we're bringing Twitch back. Welcome back, Twitch viewers. Here's our meteorology segment for the day. And today's meteorology segment is going to start out with surface winds of the North Atlantic. So we've got quite turbulent surface winds here. We've got very calm spots like here, where the winds are only at 4 miles per hour, and close by, 44 miles per hour. So turbulent waters there in the North Atlantic indeed. Let's zoom out and show you the rest of the surface winds for the Western world. There are the surface winds for the Western world. Next, the jet streams. Here are the jet streams of the Western world. Quite chaotic here in the Northern Hemisphere, all over the place. Doubled up and tripled up jet streams here over places like Africa and Europe. And some extremely cold temperatures persisting in the U.S. Here are the jet streams of the Eastern world. Quite chaotic, especially in the Northern Hemisphere there as well. Here are the surface winds of the East. And we'll zoom in on this powerful system here once again. So at least hurricane force winds there, showing at least 83 miles an hour. There's an 85 mile per hour section. So probably more like 100-mile-per-hour winds in that area there in the extreme western Pacific, several hundred miles east of Taiwan. Next, real-time lightning maps. I like to use lightningmaps.org. We just saw a major strike in the center of the country here, right in the middle of Kansas. A lone lightning strike there near St. John in Stafford County. In any case, here is the rest of the world map. It's a real-time lightning map. I just used it the other day, lightningmaps.org. Next, looking at pressure cells. Here are pressure cells as reported by windy.com. Let me just get the pressure isolines. There are the pressure isolines, folks. We'll advance this into the Euro forecast. Here's the Euro forecast for pressure at 12 noon Eastern Time tomorrow. Excuse me. Don't worry, it's not COVID. And even if it is, guess what? I don't care. Yes, that's right. I don't care. I wasn't scared of it last year on January 23rd when I started covering it at smAshomash.com/forum, and I'm not scared of it now. Here's a weather.gov map. And we still see lots of frost advisories and freeze warnings over all kinds of places like Pennsylvania, New York, New Jersey, Connecticut, Ohio, Indiana, Virginia, Kentucky, Tennessee, North Carolina, Maryland. Lots of freeze warnings there. Delaying planting in large portions of the east. Here's the temperature anomaly. According to the GFS forecast here, we're going to advance this. And you can see these temperatures around here are like 12 degrees Celsius below normal. 12 degrees Celsius. And we're going to see repeated pulses of cold weather here. Extreme cold weather here, like 16 degrees below normal Celsius in Montana, Wyoming, North Dakota, South Dakota, and Minnesota for the 24th. And then continued pulses of extreme cold. And some major temperature fluctuations happening there in the center of the country. Here's the current U.S. Doppler radar map as snow continues to fall in Montana, Wyoming, Colorado, New York, Vermont, New Hampshire, Maine, even some in Connecticut and Massachusetts and Pennsylvania. Here's the cloud layer. Here's the water vapor map. Again, cloud layer. There's a Doppler radar map. There's the cloud layer. It's too dark to see them at nighttime, so we use the 3.9 nanometer channel 7, the NASA GOES interactive weather satellite suite, and it's pretty sweet. Again, there is the water vapor. And that's where we'll end today's meteorology segment. Thanks, Twitch viewers. We'll have to see you next time. Twitch.tv/smAshomash. As it's time for bonus features. Here at the Smash News Network, least busted name in news, we enjoy bonus features. This one will be the El Teide, Spain ground-based solar observatory imagery. And you can see major filaments around the north and south poles of the sun, as well as some active regions. A filament ahead of sunspot 2816. Again, likelihood of coronal mass ejections continues. Thanks for tuning in, Smash Team. Don't forget to share the videos on your social media. And leave us a comment. Let us know what your favorite social media is. We're probably already there. And here come additional bonus features. It's the colorized magnetogram in ultra-high res, as well as the solar intensity gram. So sunspot 2817 is already set. Sunspot 2816 has degraded a bit, looking weak. Sunspot 2818 looking fairly stable. We may be seeing a trailing umbra forming here, so we're seeing some minor dark spots happening there. Behind that, if that becomes a beta-class sunspot, it will significantly increase the chances of coronal mass ejections and solar flares. Could be Sunspot 2819 forming up in the northern hemisphere. Here's a colorized magnetogram of that, and you can see indeed one dark blue spot there. So that's an area to keep an eye on. Also, this area trailing Sunspot 2818. And we see a large spread in between the leading South Pole umbra and the trailing North Pole umbra associated with Sunspot 2816 as well. And here's a full disk image at 193 angstroms. One of the many ionized wavelengths of iron, the UV emissions of ionized iron. Here's 171 angstroms, my personal favorite wavelength, and we'll close things out with the setting of Sunspot 2817. In any case, thanks for tuning in, folks. Remember to stare at the sun, attempt to understand the physics. And if you're driving, don't drink. And if you drink, don't drive. And since it'll never be now again, visit our links, support our channel, and may that solar wind be at your back.